Okay. All right, we are recording. Okay, so sensing the environment with the Raspberry Pi. My name is Kyle Wilkie. I am a special ed teacher at Santiago STEAM Magnet School. We are a public elementary school in Lake Forest, California. I was going to be teaching this with Kevin Fairchild. He is our educational technology coordinator, but as you might imagine, given our current situation when it comes to remote learning, he has his hands full, to say the least, right now. So he is not going to be joining us right now, but he did help with the creation of our project, our presentation today. All right. So our session goals for today. Now, I would have loved to have you be seen in person, and we could have been playing around with the Sense Hat. This is a real Sense Hat here. And what the Sense Hat is, and I'll cover that in just a second, but we're going to be connecting to our Sense Hat virtually using an emulator. We're going to be exploring that online emulator. And then I'm going to show you how you would display emojis using the RGB LEDs. And we're also going to be sensing the orientation and then getting some different data back from the various sensors on the Sense Hat. Now, because I'm not sure if everyone here is aware of what a Raspberry Pi is, the Raspberry Pi is a $35 computer, full-fledged computer. You need a mouse, a keyboard. You're going to need a monitor, connects via HDMI. And the Sense Hat is a device that you put on top of the Raspberry Pi that gives it a lot more features. So we'll cover those in detail in a second. Here is some other common devices that you can kind of compare to the Sense Hat. You can see how some have pros and cons, or some have some features, some don't. Microbit is very popular since it doesn't need a, it's not a computer itself. It can connect to a Chromebook, same thing with Circuit Playground. I'm not as familiar with this one over here, the Clue, but a lot of different varieties, different price points. As you can see, the Microbit, a lot cheaper. This one is going to be, the Sense Hat is going to be able to do a lot more heavy computing when it really comes down to your bang for your buck. This thing is loaded. So if you want to click on the full comparison here, we have it even more detailed on a Google numbers, Google, then whatever the Microsoft Excel version it is, can't think of it right now. All right, so here are our features. There is an 8x8 RGB LED. So RGB is red, green, blue. So we can make pretty much any color we want on our little matrix here. So we'll be using it to make a emoji, and it's really fun. A lot more fun if we were to be doing it in person. There's really nothing quite like lighting up the screen. It's extremely bright. It's a little bit blinding, but that's what makes it so much fun. Sensors, gyroscope, accelerometer, magnometer. So packed full of sensors. We're going to be accessing the pitch, yaw, and roll from the gyroscope. The accelerometer is really useful when we think about capturing motion, pressure, that kind of thing. And the magnometer is able to sense where it is in relation to the North and South Pole. Temperature and humidity sensor, a barometric pressure, as well as a mini joystick. So you can start thinking of different games that are possible using the Sense Hat. Okay, so I see we have some kindergarten, first grade. The Raspberry Pi makes an excellent first computer, in my opinion, for any student. Really opens things up. And it's also a really fun experience too of building the computer, even if it's just plugging in USB. Since this is a computer, it really kind of opens the box and doesn't hide it. So much of our devices these days, like tablets, everything is hidden. We're not really encouraged to modify or explore it, where that's the whole purpose of the Raspberry Pi, is to be piecing things together, learning. And it's really a low risk, learning environment, because if we break it, $35. And I can tell you from experience that these are really hard to break. You really have to try in order to break a Raspberry Pi. Okay. Fun fact, the Raspberry Pi Foundation, who actually owns the Raspberry Pi, who actually makes the Raspberry Pi company, there's two divisions there, but the Raspberry Pi Foundation uses all of the income from the production of the Raspberry Pi to fund various programs. One of the really neat programs is called AstroPi. And this is a really, really cool thing. So there are actually 2 Raspberry Pis on the International Space Station. So really, really cool. And they have these special cases that I think cost upwards of $2,000. So the joke is that these are the most expensive cases for the cheapest computer, right? $2,000. They added some different functionality that the SenseHat doesn't have on its own. And you can actually, people have 3D printed these and then gone through and wired the separate buttons and joysticks and whatnot in there. That's kind of a fun option if you really want to go that far. One neat thing on the AstroPi is students that live in the European Union or a part of the European Space Agency would fall under that umbrella. They can actually submit code that can be then run on the Raspberry Pi that are in the International Space Station. So talk about a motivating factor. Now, right now, NASA doesn't have a partnership with them in terms of sending code to the Raspberry Pis, unfortunately. So one option would be to find a school that's in England or in Canada or a pen pal. We call them a code pal, and you send them the code and maybe they'll run it up for you. So yeah, all right. So this is how you put on a SenseHat onto the Raspberry Pi. This is the, if you look at the pointer here, this is the GPIO pins. And you might be familiar if you've ever done any like simple projects with the Raspberry Pi, is the first thing you usually do is you turn on an LED, and we use the GPIO pins to program that LED. The SenseHat uses those same pins, but instead of having things plugged in one by one, it's just a whole thing that sits down right on top. I don't know if I've mentioned it yet, but a HAT stands for hardware accessory on top, because that's what it is. It's a hardware accessory that goes on top of the Raspberry Pi. Okay, now the Raspberry Pi itself has an emulator that comes built into Raspbian. So you can actually do all types of fun stuff just with the Raspberry Pi, and you can do all types of testing of the SenseHat, and you can basically code it as if you were to own one yourself. Now, the nice people at Trinket, if you're not familiar with Trinket, it is a website that allows you to code in Python and other languages as well. And the Raspberry Pi Foundation partnered with them, and there's actually a full-fledged emulator of a Raspberry Pi with a SenseHat. So this will be our first code that we run here. But this is Python. This is Python 3. And I'm actually able to program this virtual Pi using the Python over here. And we'll be able to basically access all the features that we would normally want to on a physical SenseHat with a Raspberry Pi. So this is super powerful because one of the barriers of using Raspberry Pis in the classroom is that you need to have a monitor or other various devices of looking at the screen, keyboard and mouse. And so one of the nice things about this is that if you have one Raspberry Pi set up at your school, you can use this emulator on a Chromebook, copy the code here, and then paste it in using various methods into the Raspberry Pi, and now you're able to kind of expand on the accessibility of one SenseHat setup. Okay, now the first thing we do on a Raspberry Pi with a SenseHat is we have to put it on top. If we try and put this when this is on, we can actually end up damaging the Raspberry Pi. So what we always do first is we turn off the Raspberry Pi, unplug the power, and we put the SenseHat on. What will happen is when it's turning on, you'll see a lot of pretty rainbow colors. And then if it's successful, the rainbow colors will disappear. And that's how you know that, at least at some point, that it's working. First thing we would be doing is we'd be testing out the emulator. This is just a fun little code, and I have it right here. Now, because we're running this online, we're not using the library from SenseHat EMU. This is considering itself an actual Raspberry Pi, so we're going to be using the language as if we were actually on a Raspberry Pi. So just to run over the code, this is our library. We're importing the SenseHat from the library SenseHat. We're defining sense, and this is just our variable. We're going to be calling on top of that, calling on it. we're calling sense is our sense hat. So we're saying whenever we say sense, we want to talk to the sense hat, and we're telling it that we want to show a message, hello world. So we're going over here, press play, and it runs the code. And so you can see the scrolling text on the Raspberry Pi. Pretty cool. If you wanted to modify this text inside there, all we would have to do is edit the text here. So we could say, hello, virtual queue. So we'd run the code, and we'll get some nice text. Hello, virtual queue. All right. So this is a really fun way of not only just testing to make sure that the sense hat is connected correctly to the Raspberry Pi, but it's just a very satisfying instant gratification. We get to make use of those really pretty LEDs, RGB LEDs on the screen. Okay. All right. So we've successfully done that. We're going to move on to color mixing. Now, I mentioned earlier that the RGB matrix on the Raspberry Pi is RGB, red, green, blue. And we can make basically any color that we want by adjusting the numbers in our code based from 0 to 255. If you're wondering what this number is here, I believe it is considered a hexadecimal. So if you're familiar with like Photoshop or some of those more advanced graphic design stuff, this number will make sense to you. If you're an elementary school teacher like me, I don't understand this number. It doesn't mean much to me, but to each their own. Okay, so, but you can see how you can really come up with some interesting colors and play around with different art projects you're doing. This is a really great tool to use. This is a really fun GIF. Okay, so how do we use that on the sense hat? So this is our code that we're gonna be running here in a minute. Again, we're importing sense hat from the sense hat library. We're also importing time. This time we're importing time from sleep. We're defining our sense hat, and we're also defining red. And we're telling, when we call upon red, we want red to be, here's R, G, B. So you have our red, green, blue, and we want red to be 100% on the first one, on the R. Sense clear, what this code does is this tells the entire sense hat to go all red. The sleep, it tells whatever command happened before, it's just telling it to do it for that amount of time. And then sense clear, which sounds like it might, if it's because there's no red here, sense clear says to clear out the whole sense hat. And then sense set pixel, which does exactly what it sounds like. It's going to set 1 pixel to a certain color. This is also a fun way of teaching coordinate planes. We're going to go over 4 and up 5. One fact that's kind of interesting is on the sense hat, it actually starts at 0, 0 instead of 1, 1. Or no, it starts at 1, 1 instead of 0, 0, I believe. We'll check it in a second. And then we're telling it to turn red and then sleeps for 1 second. Oh, okay. So Sarah let us know that there is a Chrome extension called Color Picker that tells you, oh, that's very cool, any color off a website, and also tells you what hexadecimal number it is. So there you go, Chrome extension called Color Picker. Very useful. All right, so let's go ahead and try this out. Let's see. Okay, here it is, right here. So we have it all set up. We're going to run it. The whole screen turns red, 1 pixel turns on, and then it scrolls the message red. All right. Now, if we wanted to mess around with this a little bit, so say we want to change red, we can actually leave the text here as red, and we can just play around with the numbers here. So if I crank this one all the way up to 255, and then I run it, it's now going to change it to red plus green. And then it changes this to the next one there. So you can see that again, it's combining, it's going all the way red, all the way green, and it makes that new color. If I add all of them up together, Any guesses on what color that's going to be? It's going to be white. If I turn all of them all the way up, it makes it turn white. So this is kind of a fun little thing that you can play around with, is setting the clear. One thing, one little project I did was during 4th of July, I had it set up where it would scroll between full red, red, white, and blue. It would go full red, white, and blue, and then I had scrolling the message, Happy 4th of July, right? And there's a little project, and I made it into a necklace, and I had a little battery pack in my pocket, and so it was, as I was walking to the fireworks show, it was flashing red, white, and blue, and then saying Happy 4th of July. Now, mind you, the problem was is that anytime it got unplugged, I didn't have it coded correctly to where it would continue with the program, so it just shut off, sadly, and that was the end of that. But still a fun little project that you can do with the Raspberry Pi. So one of the next challenges would be, can you create these new colors? Could you create green? Could you create blue, magenta, cyan? These are all things you can do by color mixing. Can you create a new pixel location? So when we did our first run here, the pixel location, I want to say it was one of these here. So one of the things you can do is we can change this. So maybe I want to go to 7. It's 8 by 8, right? So I can't go very, very high. But if we were to change those and then I run it, it's going to go full clear. And now our pixel's over here. So a fun thing to do with students is to challenge them and map it out. You know, where does it start? Where is 0, 0? One way to have them, you know, some of your students might automatically put 0, 0 and be clever, but that's one way to do it. So if we were to do 5, 5, let's do 0, 0 since I mentioned it. Okay, we'll do 0, 0. We'll run it. It's going to go full. It's going to go, and then 0, 0 is actually up here. So there you go. All right. And then the other challenge would be, can you have students set up pixels in certain parts of the RGB matrix? Awesome. All right. Yes, if you want this slide, it's actually on the, if you can see it at the bottom here, it's the bit.ly is, my Google thing is covering it. bit.ly, bit.ly/sensitivepi. Sensitive Pi. Pies have a heart too, everyone. Pies have a heart too. So that's how you can find the slides. Displaying emojis. Now this is probably one of the most fun ways of using this with your students. I mean, I have fun doing it every time I do this. So the way we do this is we create a list. This is a list. Now this is structured this way just because it makes sense in our heads. We could have this listed out all the way to the right, but that would be a nightmare for us to try and know, you know, where does this W, if we had this on a long list, where does this W correspond to our piece here, right? That would be really difficult. So we've structured it this way just because it makes sense to our eyes logically. If I change this W here, that means that this LED is now going to be white. If I change this one to W, now the left eye is now white. And then we have sense.set pixels to smile. So we're creating there's a special word for it. And it's a list, that's what it's called. I already mentioned that. It's a list. So we're setting our colors up here. Now notice before we had it as red equals 255. And we had spelled out white equals, you know, whatever it was. We don't have to do that. These are just variables. So we can designate these as anything we want. We wouldn't want to spell out red here because then we'd have to type out red on each of these pieces. That'd be very tedious. When we're trying to code something, we want to work as efficiently as possible. That is why we have that set up the way it is. Okay, awesome. If you notice these over here, anytime in Python you use a hashtag, or if you want to call it the pound sign, what this does is this tells Python or the computer to ignore anything that happens after that. So it's a nice way of taking notes. So, you might know, if you're a somewhat advanced coder, that this piece of code here says that this makes the color red. But when you're getting started or you start to have bigger projects, it really makes a lot of sense to make comments in your code. And that way, if you ever run into issues when you're coding, you can easily find markers of like, oh, look at, this is the instruction set for this task or this feature in my program. Okay, find this. Okay, so here is our code. We have it all laid out. I'm gonna press run. I was kind of playing with this earlier, so the colors might not be what we had on there. Let's see. Okay, and it's not doing anything because it's already there. So if I refresh this, let's see what it does. It's still showing. So let's play around with this a little bit. I'm going to adjust the R here. So I'm gonna give it bigger eyes. So I'm gonna go R here, and that's gonna change this LED. I'm gonna come over here and change this W to an R. And then, you know what? This character here, this is a sad character now. So we're actually gonna modify our code, and we're gonna make this a sad face. Because I was really hoping that everyone would be able to do this in person. But that's okay. One thing that you can, if you notice, is my virtual background has a lot of sponsors of Q. And as you might imagine, given that this was going from a real life event to a virtual event, those sponsors really are helping out and making sure this whole thing happens still. So props to all of them. Okay, so I'm gonna run this code. We're gonna see what happens, and hopefully it works. Okay, and now we have a sad face. Now notice, I forgot one of the pieces there. So we have a straggler, this little R here. This needs to be a W. And let's run it. And now we have a sad face. If we wanted to, we could add some tears. I don't feel like I'm emotionally in that place right now to do that, so we're gonna hold off. But you can see doing a lot of emojis here is really fun. This is a really great way of exploring digital design. One thing that you can do, which is really easy, is to use like tables in Google Docs or just any type of graph paper and have students lay out like what they want to design, kind of like 8-bit design, and have them designate each one. Okay, what do I want my left corner to be? How can I take a design from like a photo? How do I translate that into 8 by 8? There's a lot of different process that you have to go through to figure out that process, because it's pretty complicated, right? You're taking very high detail to low detail, but it's really fun. One of the classics is the Minecraft creeper. It's really fun. Okay, so that is displaying emojis using the Sense Hat. All right, moving right along, we have the Sense Hat orientation. So the Sense Hat can detect its orientation in 3 axes. We have pitch, roll, and yaw. Yaw is always my favorite, just because it's fun to say yaw. So you can look at this little display here, or this little design, and it kind of goes over the way that we know which part is what. The best way that I always like to look at it is if we were to look at the Raspberry Pi, the USB ports and the Ethernet port are like the engines of a plane or a jet. So pitch, if we look at pitch is going to be going vertical. So it's like it's tipping forward, almost like the if this Raspberry Pi plane was taking off. I'm going to demonstrate this using one of the Raspberry Pis here, or the emulators. Okay, right here. So I already have it set up here. So we're pretending that these are the engines, right? And pitch is this one. So if it's flat, my pitch, it's just not going to show this because of the way it is originally set up. But if we're pretending that this is 0, my pitch is going to be increasing in one way if I go up. So if you've ever been to John Wayne Airport, you know that when you take off, you go from this to this in like no time. It's quite rapid. And then when you land, it's the same way, just the opposite, right? You're like this and then, right? So that's a fun little way of explaining it. And we have roll. So it's hard to do this on the emulator because I can't really grab it very well, but roll is this way, kind of like a bear roll. We're kind of twisting the Raspberry Pi this way. So you can see if I can barrel, I can kind of do it with this, but it's a little tedious. Okay, and then ya. My favorite one to say is ya. And then when we're all done with this section and I ask if everyone understands, everyone can just say, oh yeah. Okay, there's a free one for you. Okay, so ya is this. It's like sliding or it's twisting. This is ya. Okay, all right. So let's take a look at our code. We have from the SenseHat, we're using that same library. This library covers everything that the SenseHat has to offer. So it's nice that you don't have to call in different pieces, right? It's just ready to go from that one library. Same variables before. Now, I don't think we've done this one yet, but this is the while true statement. So if you ever use Scratch, you know that there's the forever block. This is the forever block of Python. This is while true. Whatever I put underneath here is going to get repeated forever. First thing we're doing is we're getting some data. Now, this is the first time we've pulled data from the SenseHat. And what data do we want? We want to get the orientation of the SenseHat. We're going to be doing pitch equals data pitch. So we're defining which data we want. Because it's getting orientation, there's 3 different ones that we need to tell it. So we're defining that we want to get pitch, and we're telling from data we want to get the pitch, and we're printing it. So just like how we printed hello world, we're going to be printing the pitch. All right, here we go. Now, something that I did to just make this a little easier for everyone is I added pitch, roll, and yaw. And then in the pitch, in the print section, I had everything lay out together. So all we did was we did a similar call out for the roll and the yaw, and we're printing it right next to each other. So when we run the program, it's going to be spitting out the pitch, roll, and yaw. And actually, earlier I was playing with it, and it looks like it might be doing it backwards. It might be doing yaw, roll, pitch, but yeah. So let's run it. So you'll notice down here, it's going to start automatically printing. Now, right now, it's actually printing. We just don't know because the Raspberry Pi on the screen is not moving. The second that I pick it up, the numbers start changing because it's noticing that something's happening, right? That gyroscope is going, hey, you're moving it, I'm printing out data. So what you could kind of do is also figure out what's what is if we look at the numbers, we have 156, 338, 88. What happens if I start twisting? Which one changes the same? Which one stays the same? Which one changes the most? If you notice that middle one right now, that middle one is hardly, oh, now it's changing because I'm twisting a little bit, but it's just kind of interesting to play around with that. Now, if we actually had these, it'd be a lot easier to tell what's what, because whenever we reset the piece, then it levels out. On this one, if I reset it, it just throws it back in, and it's not exactly what we're doing right here. So, but you can see how you can play around with it, and you can get all that data. Now, what could you do with this in class? One of the best use cases I've seen of this is using this almost as a black box on a plane. So if you have your students build model planes, the Raspberry Pi is light enough to where, depending on how big of a paper airplane or model plane you have, put this on top, and then you hit record with a little battery pack, you throw it, and then it's taking data as the plane is flying. So you can almost model the flight of the aircraft, in a modeling by plugging in the data, right? Hey, look at how the pitch drastically changed at this point in the flight. It went from level flight to falling flight. Another thing that people do with this is really neat is wearable computers. So because the Raspberry Pi is so small and portable, if I attach this to a glove on my hand, so like here's my Raspberry Pi, and I do different things where I say, okay, if my pitch goes up, I want it to play a certain musical note, or if I go down, I want it to play a certain musical note, or I want to speed up the beat of a song based on different movements or different pieces, then you can do that. A lot of fun different projects you can do with the SenseHat using the gyroscope data. Okay, so yeah, that is the sensing orientation with the SenseHat. And the great thing too, I don't know if you guys know this, is that Trinket, if you tell them that you make an account and you tell them that you are a teacher, they give you a slightly upgraded account. which is kind of cool, right? I think anytime a company wants to support teachers, I think that's awesome. And again, I can't really recommend this Trinket website more, because what it allows you to do is multiply the impact of one Raspberry Pi in your classroom, or however you want to use a Raspberry Pi at your site. But basically, it allows you to code for the Raspberry Pi without even having a Raspberry Pi. So students can work on it at home, or they can work on it on Chromebooks, or whatever, and then take that code. I think the best way of transferring code from here to a Raspberry Pi is, if possible, hook the Raspberry Pi up to the internet. Now, I know that different districts have different rules on Wi-Fi. You can hook it up via Ethernet. That also works. The Raspberry Pi has a Chromium web browser, which is the same web browser that Google Chrome. It's just the open source version of that, and it's fantastic. The other way to do it would be to copy the text onto a simple text format on a USB drive, plug it in. You can drag and drop right there. It'll work perfectly. Okay, let's move on to SenseHat for humidity. So just like before, we're bringing in the library for the SenseHat. We're bringing in time this time. We're defining our variable. We're telling it, hey, there's a SenseHat on the Raspberry Pi. We're using the while true statement. Now, this is new. We have not done this yet. So while true, this is our conditional piece of code. So let's take a look at this, and you can try and guess what it's going to do. Humidity equals sense get humidity. So this is telling the SenseHat to get humidity, or it's telling it, hey, if I say humidity, get the data from the humidity sensor. If humidity is less than 35, sense clear, it's turning what color? Does anybody remember what that was? If else, sense clear, another color. I wonder what that one was. And then it's going to be sleeping for 0.1 seconds. Now, this is important because this way it's not getting it all the time, the data. We want it to have a little break in between, okay? Okay, so there's that was the other one. Okay, now here is our humidity one. Now, I also tossed in, just for time's sake, temperature. I didn't get barometric pressure because I'm just under a lot of pressure, so I decided not to do that this one. But we have humidity. We're getting humidity, and we're also getting temperature. And then this is our while true, and it's doing while true. If our humidity is going to, let's see what happens. So I'm going to run it. Now, you might wonder, well, how do I change the temperature on an emulator, right? It's not like I can actually take the temperature of a computer, even though you kind of can if it has the right sensors, right? But up here, so you can toggle these just like you can. The best way that you do it with a Raspberry Pi is, if you can't tell what the humidity in the room is you kind of breathe on a little bit, right? Hot air, and that also can change the temperature. But it's also not always the best idea to be breathing on a computer because other people might be using it. So, but yeah, so you can change the humidity here. So if I bring it up to above 35, it turns red. If I go below 35, it turns blue. So what could I use this for? Well, I mean, when it comes down to it with the Raspberry Pi, the world's your oyster when it really comes down to it, because there's infinite amounts of projects. One of the most popular ones is like a weather station. We could take the data from the humidity and have it print out the information on here. We could have it say the relative, the temperature. We could also have it tell the barometric pressure. One thing you can use the barometric pressure for is there are some really cool people who do high altitude ballooning with the Raspberry Pi, and barometric pressure is a good indicator of altitude. So that's another one. We were going to set it up to since we don't, there's a lot of logistical stuff with high altitude ballooning, price of helium, and all that kind of stuff. So we were just going to do a kite, and it'd be interesting to see just from a kite, like how much barometric pressure change occurs on a, say a 300 foot long kite string. How much did temperature change from when we started to when we got to the very top of the kite string, that kind of stuff. And if you're wondering, how on earth are you powering a Raspberry Pi from a while it's on top of the kite, I happen to have one nearby, just these standard battery packs. As long as it gives out about 5 volts, it technically needs 2.5 amps, but it's kind of forgivable. But as long as it's 5 volts, you can power this thing with the battery pack, and you can power it for a really long time. I was just recently doing a project, and I was working on this project for multiple hours on a Raspberry Pi with the same battery pack, and it barely went down like one little bar of the battery pack, right? Very impressive. It's very energy efficient. So if we look down here, it is in Celsius. So like right now, it's 22 degrees Celsius in our virtual environment. But this is actually really useful too, because if a student is building a project and obviously they can't control the temperature in the room. And so by using the emulator, you can check your code, right? I can now control my variables. So that way I don't set up my project, I turn it on, plug it in, I'm gonna have it run the whole night. And then it gets to a certain criteria, but then because of whatever bug I have in my system, it didn't work. So by doing this, I can actually plan ahead and go, okay, does my code do what I want it to, right? If it hits 50 degrees Celsius, whatever my code was doing, it can now do. Same thing with humidity. In the beginning of the year, I was in a new classroom, and it was at certain parts of the day, it would get unbelievably humid in my classroom. And I kept telling our facilities guy, and I was like, hey, like it gets really hot in there. He goes, oh, well, when I've been in there, it's been fine. I'm like, oh, well, I'll show you. And so I set up my Raspberry Pi to take data, and I did it every like 20 minutes or something. And sure enough, at like 1 o'clock every day, it was like for whatever their air conditioning was doing, the humidity would just spike. And, and the temperature would spike too. But it was just really interesting how I could feel it, obviously, because when it's humid, but the data showed it too. So that's another reason why you should get a Raspberry Pi. So you can tell everyone that my room is getting hot and I have the data. So that's a fun one. Okay, so that's the SenseHat one. So we could do it for temperature and pressure. We could put in here. So for pressure, I think it's just pressure. I think that's, let's see if I do it real quick right now, because I know we're a little short on pressure. And then equals some live coding, sense.get._ pressure. And then I'll just go here. Pressure. All right, let's see. Is it gonna work? Is it gonna give me an error? Ooh, it's not gonna work. It worked. Okay, so there you go. There's our barometric pressure, and I can play around with that and it'll change. There you go. Fun. So, but this is like the challenge, right? Once you've figured out one piece of it, you just substitute it for another piece of data. It's pretty simple. I didn't include it in the presentation, but there's some really simple code where it'll spit out all the data that you've collected to a CVC file, and you can upload that to your favorite spreadsheet program that you would like. Okay, so we have about 20-ish, 15 minutes left. I would love to take questions. I would, if you want to, if you have time, go ahead and go on to Trinket and just play around. Find one of these things that you do. If you go on to Trinket on its own, this code right here, it's actually going to give you just some demo things to do. I'll show you. So it's going to come up here. It's going to give you a bunch of different little activities, and you can try and figure out what this demo does. Here's the SenseHat, or the AstroPi that's on the International Space Station. That's the default emulator on here. If I want the Raspberry Pi, I just click this button down here, and then it starts running it there. But so some of the next steps would be, can you animate your emojis? So by taking that same emoji piece, can I go from a happy face to a sad face, right? And then can I go to a happy face to a sad face based on the humidity in the room? Right? I know my tolerance for humidity is very low, so that kind of stuff. Okay, so questions. Go ahead and toss us in the chat. SenseHat versus Adafruit Clue, opinions. I don't have a ton of experience with the Adafruit Clue. I want to say, let me go back to one of the first slides. I don't believe, I believe the Adafruit Clue is similar to the, it's similar to the Microbit and the Circuit Playground, being that this is a micro controller. So once you program it, right, it needs a computer. So just like how the Microbit, you use a website to program it and it burns the image onto it, just like a kind of a, and what's it called? Arduino, there we go, Arduino. So Circuit Playground, Express, Microbit, Adafruit Clue, all of these devices, you need to program it, right? And it's kind of burning that image on. And then that is the program that's running, okay? The Raspberry Pi is unique in that the Raspberry Pi is the computer that you're programming it with. So there's no separate layer. This is what you're programming and what you're controlling at the same time. Versus with the Microbit, I'm using a computer, Windows, Mac, Chromebook, to write the program, and I'm burning that image on it. I can't adjust that until I go back on and reprogram it. Will Trinket work with it? That's a good question. I'm not sure. I don't have a ton of Microbit experience, so that would be a question for someone else. Let's see. Visual Code. Something else that's kind of neat with the SenseHat is if you have Raspberry Pis, there is now an extension on the Raspberry Pi that you can use Scratch with the SenseHat. So you can do some simple starter programs there. That's another option. Let's see. Oh yeah, there's a good idea. So the chat, they're recommending you can always use the Microbit emulator if you wanted to use, because like the question was, can you use Trinket? Can you use Trinket to code on the Microbit? And I'll show you what Trinket looks like if we just go to the standard browser here. But when you log in, I think you do have to pay a little bit if you want certain commands and whatnot. But let's see here. So I have a new Trinket, Python 3. So this one does need a special thing here, but you have a lot of different options here, blocks, so like Scratch, HTML, music, and then just standard Python. I'm gonna go ahead and pick Python 3, because just because I can't save it on Trinket doesn't mean I can't copy and paste my code, put it into Google Drive, Google Docs, and then copy and paste it later, right? There's always a way around stuff, all these pay different things. Can you do music on Trinket? I think you can. I think that's what that was showing there. Pretty cool. Can you include the last humidity activity in the slides? I believe it is in the slides. It might just have, this is going to be recorded. I'm going to be uploading this to a link at the end of the time. I'm going to take the video and upload it somehow and then link it back to these slides. So if you have these slides, if you've gone to bit.ly /sensitive pi, then I will add it there so you'll have it. Someone just said that they have 2 Raspberry Pis and they just ordered some SenseHats. Awesome. Welcome to the family. So if we've barely just scratched the surface, obviously, of what the SenseHat can do. They have a lovely reference docs, so you can see all the fun stuff that you can do with the Raspberry Pi. So this gets into more advanced stuff, but we kind of touched into this a little bit. Flipping the image. We didn't even touch the joystick. Didn't even touch the joystick. So timestamp, direction. And it's interesting too with the joystick, just a fun fact, is there's 2 events with the joystick. There's the click and then there's the release. Kind of cool. Let's see. Oh, cool. Very fun. So Vic has copied all the code that I wrote in the demos. So if you need a copy, you can email her and her info is in the chat. Awesome. Thank you, Vic. That was super helpful. So this is super useful. This will help you get even further in. You can see get temperature, get humidity, environmental sensors, get pressure. Here's the other sensors here. So I want to give a shout out to Novel Design Labs. I was really excited to work with this company. They were going to supply all the all the Raspberry Pis and the screens that we were going to be using on this, had we been in Palm Springs. Unfortunately, we are all sheltering in place now. But really cool company. I actually found out about them on Kickstarter randomly, and then found out they were a local Laguna Beach company. And they just have a really interesting, I think it's one of the best implementations of a portable in the classroom Raspberry Pi setup. But it uses a very affordable, very widely available tablet. And then they have this nice little injection molded piece that keeps it all together, and then it fits into a binder. And I just thought it was fantastic. And the way it works, which is a little bit unique, is that the Raspberry Pi has Wi-Fi. And so you can set it up to obviously connect to Wi-Fi like normal, but then you can also set it up to actually create its own Wi-Fi network. Then what you do is you take the tablet, have it connect to the Raspberry Pi, its Wi-Fi network, and then use VNC. VNC is virtual networked computer. So I can display the screen of the Raspberry Pi without any cables or anything. And so this was just a really powerful, affordable option. You can also use the touchscreen too. So you kind of eliminate multiple things. You eliminate having to have a full-fledged display. You don't necessarily need a keyboard and a mouse, although I still prefer using that. But the students that have used this system for me were using the touchscreen, and they were like totally fine because they're touchscreen natives. So someone mentioned they just bought a few. There are suppliers of Raspberry Pis that fall under like the approved sellers. If you go on Amazon, you'll notice that there's tons of different prices and stuff out there. That's because of supply and demand or whatever, they will buy them, jack up the price, and then sell them for a lot more. There are specific suppliers, Micro Center being a local one, who actually sell these at the price that they're supposed to be sold at. So I would say support them as much as possible. Raspberry Pi, I mentioned them. I'm not using the Model 4 today, and the one that we were using on the emulator was a Model like 3. Not that that really matters. It just has to do with the different ports that are available. This one has micro HDMI and a USB-C for power. If that doesn't mean anything to you, then that's fine. It's just different ports and stuff. Let's see, any more questions? If anybody wants to turn on their mic and ask a question or anything, feel free. I believe you can do that on your own. I think I gave you guys permission to do that. Yeah. I'm going to go back to the bottom. I want to see if there's anything else I left down there. So different things here. Different projects as the AstroPi, Magic 8-Ball, which is really uses the accelerometer. So it's waiting for a shake of the accelerometer, and then it gives you a little, Magic 8-Ball question, yes or no, maybe, that kind of stuff. Minecraft Space Explorer. So if you're not familiar with the Raspberry Pi, it comes with a free copy. This is if you're using Raspbian. It comes with a free copy of a Minecraft Pi, which is a version of Minecraft that works on the Raspberry Pi. You can actually program Minecraft using Python on here to interact with different things. So one of the really cool things you can do is in Minecraft, say you're looking for a gold block in Minecraft. You can have it coded to where the sense hat will start glowing yellow if I get closer to the certain blocks, right? It's a really neat way of combining the digital world with the real world, right? Whenever students kind of start seeing these interactions, it's one thing when they're on various online things and they've told a little rabbit to move 5 steps, or they've done things. It's one thing when they start seeing the real world and the physical world, the virtual world and the physical world interacting with one another. There's just something really powerful about that interaction. That, speaking of that, would be the marble maze. So using that accelerometer and the gyroscope, one of the little LEDs gets lit up, and it's like a marble. So then you have to try and get it through the maze while moving around the sense hat. Pretty cool. Let's see. And then I mentioned this before. Shout out to them. If you have any questions, I'm available I'm on Twitter. I'm always tweeting about Raspberry Pi stuff. It looks like I didn't include my Raspberry Pi, my @Twitter one. So I'm Kyle, @KyleJ.Wilkie. Would love to talk about Raspberry Pi. The way I found out about all this stuff about Raspberry Pi is I went to something called Picademy. I forgot to link that, Picademy. PyCademy is an amazing, amazing program that the Raspberry Pi Foundation puts on, and it is free professional development for teachers put on by, it's a 2-day training, and they run you through one of the sections is what we just did today, and a lot of other things from motors and all the different like camera modules. They've just recently announced the 2020 times. I'm sure that this will change given the our sheltering in place restrictions right now when it comes to groups and stuff. But this is definitely something to check out in the future. For any reason, just the networking, they do give you a Raspberry Pi, which is super generous. They're just an awesome, awesome company. Also, make sure you hop on. I think I linked to it, but ProjectWise, there's tons and tons of free step-by-step instructions of projects, basically. And so if I click on hardware and we have SenseHat, now you've got, boom, all of these, and these are step-by-step instructions, student-guided things, right? So you can get your SenseHats with your students, say, pick one of these projects and go, right? There's nothing more powerful than giving the kids the keys to the car and letting them explore. Here's that one with the exploring space of Minecraft. I mean, look at this. You got a digital, like this is just so cool. Like a Minecraft space station, and they're like floating up there. Incredible. And then I don't know. Oh, I see. So I think what it is the this is really cool. So the SenseHat is what's controlling the pitch and yaw of the space station. So that's fun. But yeah, definitely connect with us. Kevin's also on Twitter, and let's see. That's about it. If you have any other questions, feel free to unmute yourself. I'm gonna unmute all, and if you have any questions, go for it.
Yeah. Hey, Kyle, can you hear me?
Yeah, I can hear you.
Hey, this is Vic from Kelsey Fortune.
Hi.
Hey, I was just wondering, do you think it would be a good idea for me to have my kids do the code in both Python and JavaScript so they could start getting a sense of a front end and a back end if they want to eventually pursue full stack?
That is a good question, and that is a little above my knowledge. My experience is just in Python and Scratch, and so if you can make that work, I think that's awesome. I'm not sure on the programmability. I'm sure there is information out there on programming the SenseHat in, you said JavaScript?
Yeah, because I think it said in the beginning that it takes JavaScript as well.
I believe that you have Trinket. I think Trinket has an option for JavaScript.
Okay.
So I believe that's I'm sure there are programming different software you can get on the Raspberry Pi to program in almost any language, but I don't have any experience in that side of things. But
in that specific stack, no worries.
Yeah.
Thank you.
Their forums are like some of the best supported forums out there when it comes to these single board, computers. So if you have a question, I'm sure there's someone out there that has the answer, will be on the forums, and they're like super enthusiastic and helpful on there. Yeah, any other questions? We have about 2 more minutes. So glad. Thank you for coming, everyone. Make sure that you do check out PyCademy. Again, can't recommend it enough. One thing you can do, since we're have all this time at home, is what's it called? Future Learn. So Future Learn, I should have linked this. I'll put it in there before I go home. I'm home before I log off. Raspberry Pi. So they've partnered with this company called Future Learn, and they make like online classes. And so you can explore all their different online classes. They have everything from exploring physical computing to running a code club to some more like higher end stuff. So Vic, that might be something that you can look into too on here.
Thank you.
But yeah, they have a lot of great stuff. It's all free. The only thing, if you want to get like a certificate, you can pay for it, but I mean, but yeah, it's really good stuff out there. So I'll link to this in the end of the presentation. All right, very cool. All right, everyone, thank you so much for coming, and I hope this was useful. Adios.